So to start this unit, let's look at some vocabulary that we need to know. So on page 2, we start with some very basic definitions. So a point is a point in space that we name with an uppercase letter. A plane is something you might not have experienced a lot. So think of it like a sheet of paper. So it's a flat two-dimensional surface, and we name that using either 3 points on it. So we could name this M, J. Okay, so I could say this is plane JKM, or I could just put a uppercase X next to it and say that this is plane X. A ray is only part of a line, so it starts from a point and then goes off forever in one direction. So if I call this MN, the order matters because you then draw the one-sided arrow in the direction that it's going. A line goes on forever in both directions. So we could call this MN, or you can use one lowercase letter, so if we call this L, or line L. Line segment is a line that stops at both sides. So when I write it, you're going to use the endpoints, and there's no arrows on the line above it. An angle. So we talked a lot about angles in our triangle congruence unit. The angle is the space in between two rays. So right here is the angle. So we name that based off of the letters. So this angle is angle ABC as well as CBA. What matters is that the vertex is still in the middle, or you can simply call it angle B, or our trick is to put a number inside and call it angle 1. A right angle, you guys should know, is at 90 degrees. It forms a corner. Vertical angles, you should also know, they are formed by intersecting lines. And we also know that these angles are congruent. An adjacent angle we haven't talked about as much, but these are angles that live right next to each other. So if I draw angles that share a ray, so angle 1 and angle 2 are adjacent because they have this ray in common. Supplementary angles, you should also know, they're linear pairs because they add up to a straight line, which is 180 degrees. So angles 1 and 2 are supplementary. Similarly, complementary adds up to 90 degrees. So here, angles 1 and 2 are complementary because they form a right angle. Parallel lines are very important. It's a large part of this unit. Parallel lines are lines that never touch. So in this case, lines M and N are parallel, whereas perpendicular lines do intersect, and they specifically intersect at a right angle. And we use our little M and then perpendicular sign. So with that knowledge, we then go on to naming angles practice. So I can call this angle DEF because I trace the path of this angle. I can go the other way. I can also just call it by the vertex since there's no other shared angle, or angle 2. So I'm going to go through and do the same thing. So the first thing I like to do is trace the path. Angle HFG can go the opposite way. Also angle F and angle 4. Trace the path. So we start with angle NOM. Flip it for MON. Angle O. Angle 3. So again, the angle is the part in between the two rays. Trace the path, PQR. Now I could go the opposite way for RQP, angle Q for just the vertex, angle 5, again, trace the path, EDF, opposite, FDE, angle D, angle 2, FGH, HGF, angle G, or angle A. All valid ways to name these angles. Now, the total measure of adjacent angles around a point is 360 degrees, right? If you tell someone to spin at 360 degrees, they're going to end right where they stop. That's not a circle. They're going to end where they start, right? So if we start here and we spin 360 degrees, you end right where you stop. So you're forming a full circle, right? So we're spinning around. So if I form all of these adjacent angles around this point, I know that these three angles have to add up to 360 degrees, right? Because again, I can draw a circle. Ideally, it would be a true circle. And I know that these three angles have to add up to 360 degrees. So 133 plus 147 plus my missing angle K is equal to 360. I add the two together here. So that gives me 0, 180. The 7 goes there. 280. 280 plus K is equal to 360. Now you have a one-step equation. Subtract to get the variable by itself. And you're left with K is 120 degrees. Because I know that the three angles around a point have to add up to 360 degrees. We also know that vertical angles have equal measure. They are congruent. So two angles are vertical if their sides form opposite rays. Again, it's a bow tie. If you stand here and you look across, this is my vertical angle. They're asking me for the measurement of TRV. This is rather simple because these are vertical angles, so that angle is the same, 52 degrees. Supplementary angles, we said, have a sum of 180 degrees. And this angle right here is a 90-degree angle. So I know that I have three angles here. I have 72, 90, and a mystery X. So this is what I want to find. So again, I'm going to set up an equation. Adding my three angles together to get 180. I combine like terms on one side. One-step equation. Get rid of everything besides the variable to get your value of X 18 degrees. X is 18 degrees. Now this is an interesting exercise because you're going to be asked for the angle measurements, but also the reason. So give a relationship that allows you to say that. So if I look at angle 1 here, I know that angle 1 is supplementary to 145 degrees. Since it is supplementary, I know that 145 plus this value has to equal 180. So all I have to do is solve for X. And I get X is 35 degrees. Now when I look at the second picture, angle 2 is vertical to 40 degrees. So because of that, I know that it is also equal to 40 degrees. Now when I look at angle 3 and angle 2 form a straight angle. So these are a supplementary pair. So angle 3 is supplementary to angle 2. Therefore, 40 plus angle 3, we'll call it Y, must equal 180. Subtract 40 from both sides. So y should be equal to 140 degrees. Now to get angle 4, you could do two different things. You could either say that 4 and 40 degrees have to add up to 180 to get 140, or you could also see that angle 3 and angle 4 are vertical angles, so therefore they must be congruent. So I'll say that angle 4 is vertical to angle 3. So let's first look at the relationship. So this relationship is a supplementary relationship. So I know that these two added together must equal 180. I set up my equation and I solve. To get x is 36 degrees. These three together form a straight angle, so they are supplementary. So I'm going to state 82 plus d is equal to 180. Now this is different because first you have to combine like terms before you can start moving things over. So I have 180 equals 82 plus 2d. Next I subtract 82 because I want the variable by itself. I get 98. Last step, get rid of the 2 by doing the opposite. Divide by 2. I should get 49. So D is equal to 49 degrees. Here, the relationship that I have is vertical, so I know that the angles are the same, they're congruent, so I'm going to set these two equal to each other. I have a two-step equation. First, get rid of the addition. So I get 2x is equal to 90. Divide by 2. I get x is equal to 45. They didn't specify what to solve for here, so I'm just going to leave it there. If you did want to find the value of any given angle using x, you would have to plug in. Here we have angles surrounding a point, so they form a circle. So I know that I'm going to have to add up to 360 degrees. So 360 is equal to 91 plus 91 plus 91 plus x plus x plus x. So that is 273 plus 3x. Now I have a two-step equation. Subtract first. Crosses out. So we get 3x equals 87. Divide both sides by 3. So we get x is equal to 29. Okay, and then the next page is your homework. So use your angle relationships to set up correct equations to solve for the missing variables.